Hello and welcome to Chapter 1, Section 3, Inverse of a Function. The essential question is, how are a function and its inverse related? What you will learn is how to find the inverses of relations, how to explore inverses of functions, and how to find inverses of functions algebraically. All right, so example 1, here we have inverse relationships. So an inverse relation switches the input and the output values of the original relation. When the relation contains A and B, the inverse contains BA. So it's pretty simple. So here we have an ordered pair. So we have the ordered pair -4, 7. The inverse relation of this ordered pair is -7, -4. All we're doing is we are switching the places of our ordered pairs. Okay, so inverse relations, inverse functions are basically like the opposites, right? They work in the exact opposite. We're just switching the places. Same thing with an input and output table. If I have an input of -1 and an output of 5, the inverse relation will have an input of 5 and then an output of -1. So notice how they are just switching places. This is an inverse relationship. Okay, if two functions have this as a relationship, okay, then they are considered to be inverse relations. Okay, example 2. How to write a formula for the input of a function. So what we're going to do here is we are going to solve for y. Solve for y, solve for x. Oh, it says solve the function for x. Okay, so we're going to solve for x, meaning we're going to leave the x variable by itself. Okay, so I'm going to start with my original function, which is f of x equals 2x plus 1. All right, so what we're going to do here is we can't solve for this unless this is a single variable. So that's why it says solve for y equals f of x. So I'm going to change this f of x to a y. Okay, it's a simple switch that I'm doing here. I'm just making that f of x into a y. All right, and then I'm going to solve for x, right? So I'm going to leave the x by itself. Okay, I'm writing a formula for the input. The input is x. Okay, so what I'm going to do is I'm going to leave the x by itself. So I'm going to start to remove things from the right side of the equation, move them to the left so I can leave the x by itself. All right, so the first step in removing everything on the side of the x is to subtract 1. So I'm going to go ahead and subtract 1 from both sides of our equation. Y minus 1. I cannot subtract y from 1, so I'm just going to write them next to each other. I'm going to bring down my 2x because I didn't even do anything to it, and then positive 1 minus 1, that's gone. Okay, so there's nothing left after the 2x. Then I'm going to do one more step. I'm going to divide by 2 because this is a multiplication. So I'm going to divide both sides of my equation by 2. My 2's will cancel out, leaving the x alone. And then I'm going to have y minus 1 over 2. I now have my x by itself. I have solved for x. Remember that solving means to leave that variable by itself. So I solved for x. I've left it by itself. This is my formula. So I'm going to go ahead and type that formula in. So I have x is equal to, I'm going to go ahead and type the x first and then the other part of the equation. Y minus 1. I'll put that minus 1 over 2. And that is my formula for the input. I have solved for x. I've left x by itself. All right, and then there's the second part of the question. It's asking me to find the input when the output is -3. Okay, so what that means, I need to find the input. I need to find this. This is input. When the output is always y, is -3. So what that is telling me to do is they want me to replace the -3 with the y and then see what the x value is. All right, so I'm going to go ahead and give myself some space right here. All right, and then I'm going to go ahead and do this. Y minus 1 over 2 is equal to x. Okay, so what I want to do is I'm going to go ahead and switch my y with the -3. So they want us to solve when the output, or y, is -3. So I'm just replacing the y with a -3, and then I'm going to solve. Okay, so the first thing I'm going to do is solve the numerator. So I have -3 minus 1. That's -4 over 2 is equal to x. And then I'm going to do the division. -4 divided by 2. That's going to give me x is equal to positive divided by a negative is a negative. 4 divided by 2 is 2. So my input value is -2. So I'm going to type that over here as x is equal to -2. And there you have it. That is how you write the formula for the input of a function. Okay, I'm solving for x. And then I am solving for the input when my output is -3. All right, so next we're going to go ahead and find the inverse function. Okay, so we're going to find an inverse function. It's very similar to what we just did in solving for x. Okay, except it's included with one other step. Okay, so finding the inverse of a function. So if I have a function, let me make that in black for original. If I have a function of x, 4x minus 9. Okay, in order to find the inverse of this function, meaning the function that works exactly opposite of this function, I am going to follow these steps. So the first thing we want to do is I want to replace this with y. Okay, set y equal to f of x. So I'm going to change the f of x into a y. That's my step number 1. My step number 2 is to switch the x and the y in the equation. Okay, so I'm going to go ahead and do a switch. Okay, so I'm going to do this. I'm going to switch that x with that y. I'm just going to switch their places. So now I'm going to have x is equal to 4y minus 9. Okay, so I just switched places with the x and the y. Okay, next up, I have to solve the equation for y. So I'm going to do what I did in the other problem where this time I am solving for y. So I'm going to solve for y. I'm going to add 9. Okay, so I'm getting rid of the subtraction by adding the 9 to both sides. I can't add x and 9, so I just write them next to each other. And then I have 4y, the 9 is gone. And then the last step is to divide by 4. Because of the multiplication, it's the inverse. So then that cancels out, and I get y is equal to x plus 9 over 4. All right, now one thing that we have to do, because this is a function and it started as a function notation, okay, which is this f of x form, in order to identify this as an inverse function, I'm going to change the y back to function notation. So I need to do this just to finalize the problem. So I'm going to go ahead and call this g of x. I'm changing the y to a g of x. Remember, function notation could be any letter. It doesn't have to be g. I could make this b of x, or t of x, or any variable except for f, y, or x. So I'm going to leave it like that. This is the inverse of our original function. And let me go ahead and just show you guys what it means by that. So this is inverse because, look, in the first equation, we're subtracting 9. In our inverse function, we're adding 9. In our original function, we were multiplying by 4. In our inverse function, we are dividing by 4. Okay, so these two functions, okay, work as opposites of each other. All right, that is the end of this lesson. In this lesson, you should have learned what inverse functions are, how a function and its inverse are related, and how to find the inverse function algebraically. If you have any comments, questions, or concerns, please post them in the comment section down below, and I will see you all next time.